Assalamualaikum. In this video, I'm going to show you about the inverse of Laplace transform as well as the Laplace transform, and then how to solve the initial value problem by using the Laplace transform. Okay, so I took these questions from the previous final exam question. So let's try to discuss one by one. The question asks you to find the inverse of Laplace transform of the following function. Inverse, okay? Inverse of Laplace transform means that you need to find out the Laplace inverse. Let's say you name this function, okay? You name this function as fs. You can name any kind of name for that particular function. Asalkan you name the function as in the form of complex frequency domain lah, fs lah, jangan namakan sebagai ft because of this function in f's domain. Okay, so take the Laplace inverse of your fs, which is I just write down as fs. Okay, so Laplace inverse of 3s s square plus 4 plus 5 over s square. Okay, so that I try to apply the linearity property. Okay, so I split this into two. Okay, so I have here is a constant. I take out constant, okay, from my Laplace inverse. So I take the remainder, Laplace inverse of the remainder, s square plus 4. This one is also a constant, so I take it out. So this one. Okay, so I have 3 is 3 s square plus 4. We know that Laplace inverse s over s square plus 4 is cos at. At, how to get a? This one is a square equals to 4, therefore a equals to 2, so cos 2t, okay, plus 5. And then I take a look at this function. I know that when I have s to the power of greater than 1, okay, so it either you have t to the n or something cosine sine, okay, but cosine sine hyperbolic and cosine hyperbolic, you must have something s square or plus or minus with a square, okay, but now you don't have a square, so that it is just t to the power of n. In order to get the answer in the form of t to the power of n, you must have the function n factorial over sn plus 1. Okay, so that you have s square. So I have s square is s1 plus 1, and then should be n and n factorial upward here. So I have 1. Okay, and luckily I just have 1 here, so that the answer is actually t to the n equals to, sorry, t to the n equals to 1. Okay, so this one is 5t. Okay, you can always check your solution. Okay, what I said in class, you know that this is your ft. Okay, so just take the Laplace transform of ft. So 3 is just a constant, take it out from your Laplace. So cos 2t, okay, plus 5 Laplace of t, so that I will have 3 cosine is s square plus a square, so I have 4. Okay, and then I have 5. This one t is 1 over s square, so I have 3s s square plus 4 plus 5 over s square, which is similar to the original fs, so that I can conclude that this is my correct ft. Okay, so this is my correct ft, this one. Okay, and then when I check, I got the same solution as presented in my question. Okay, all right, so I continue for the question C. Okay, question C, show that, okay, sorry, a differential equation is given by y prime plus 4y equals to 5e negative t, y equals to 1 when t equals to 0. This one is also can be written as ty dt plus 4y as a function of t equals to 5e negative t. Okay, y equals to 1 when t equals to 0. Right, so just the same thing. Okay, whether you can write this one like this or like this. But the most important thing is you must understand that in the Laplace transform, okay, the initial differential equation must be given in the form of t, because we want to transform the time domain to the complex frequency domain. Okay, so that is the idea. Okay, so now let's go to the first question. Show that ys equals to s plus 6 over s plus 1, s plus 4. Okay, 5 marks. So now the question is actually guide you. Okay, so let's take a look at the second question. Second question, based on ys in question 2c1, find the solution of the given differential equation. So actually the question is this one. Okay, the according to the what you call it, according to the discussion that we have done during our synchronous class, we know that we try to find out the solution of y. The solution of the differential equation is yt. We want to know what is our yt. Okay, the problem is after we do the transformation, the solution in S domain. Okay, so kalau kita tengok sini, if we can take a look at the step of solution, first of all we need to take the Laplace transform both sides of the equation, and then we need to substitute the initial condition, then only we can get the ys. So in order to answer the first question here, okay, you must do these three steps first. Okay, so the first three steps in order to get what is your ys. So in this question, you are very lucky because the question is already guide you. The question is already show you what is your ys, so that you have been guided in order to get the ys. So your 5 marks mesti dah ada dalam tangan. Okay, so next we continue in order to get yt, because the second question is dia kata apa? Find the solution. Find the solution means that what is your yt? Itu dia. What is your yt? Okay, based on the differential equation. So your yt can be obtained by taking the Laplace inverse of your ys. This one. Inverse of this one. Okay, so let's say lah. Let's say you kita macam stuck kan, kita tak tahu macam mana nak how to get the first how to get the ys. So at least you can try to solve for yt, because in order to get yt, you must take the Laplace inverse of ys. Itu pun kalau awak tahu. Okay, so sekarang ni saya dah bagi tahu. Okay, I keep repeating the same information to you. So I really hope that you can understand very well lah this one. Okay, so now we continue. Okay, so let's try to solve for this one first, ys. So what are the steps? Take the Laplace transform both sides of the equation, substitute initial condition, then try to rearrange until you get only ys on your left hand side of your equation. So let's try to solve this one. All right. So given that y prime plus 4y equals to 5e negative t. Okay, condition y equals to 1 when t0. Okay, so duduk jauh-jauh dulu yang condition tu. So try to take the Laplace transform. Okay, so by taking the Laplace transform of y prime, tengok balik table kata apa, y prime. Okay, saya boleh tengok dekat sini. Okay, so y prime is this one. Okay, y prime is sys y0. Alright, so you will have here is sys minus y0. Tutup kurungan. Siap. Tutup kurungan and then plus 4. 4y. Y apa? Kalau y ni tadi saya bagi tahu y is a function of t kan, yt kan. So kalau lah kita kata Laplace ft equals to fs, Laplace gt equals to gs. So Laplace yt equals to ys. Okay, so 5 is 5, taking the Laplace transform of e negative t, so you have 1 over s plus 1. Dah nampak dah tu, macam sama kan, dan nak sama dah kan. Okay, so relax. Okay, so we continue. So the next step is substitute the initial condition. Okay, so equals to 1, so this one equals to 1, so I will have s ys minus 1 plus 4 ys equals to 5 over s plus 1. They need 5, okay? S plus 1. Alright, so our target is we just want to remain ys in our left hand side of our equation. Okay, so the rest will be brought to your right hand side. So sekarang ni ada negative 1 bawa ke sana. So saya ada ys, I will have ys s plus 4. Okay, so 5 s plus 1. Okay, bawa ni ke sana, so dia akan jadi plus 1. So plus 1. Alright, so we continue ys equals to 5 s plus 1. Okay, ini bawa pergi ke sana. Okay, bring it to your right hand side of your equation. S plus 4 belongs to this one and as well as belongs to this one. So it will become s plus 4 plus 1 over s plus 4. Okay, so this is our ys. So we try to make the we try to adjust, okay, the denominator. So I will have 5 over here I have s plus 4, here is also I have s plus 4. So apa yang tak ada dekat sini? Okay, only s plus 1. So I try to multiply this one by s plus 1. Okay, denominator and numerator, so that when I cancel out, I will get the same function as 1 over s plus 4. So I need to multiply by s plus 1 at numerator and denominator. So I have 5 plus s plus 1, okay, over s plus 1 s plus 4. So I will have here I try to make it very nice. So s plus 5 plus 1 is 6. Okay, s plus 1 s plus 4. So is it same as the stated in the 1? So I have s plus 6 over s plus 1 plus times s plus 4. Okay, nice. We have proven that we have proved that we have the same ys as stated in the question, because the question asks you to show that. Show that means that you must get that solution. Okay, unless kalau soalan tu silap lah. Okay, so please be careful with the wordings in the question. Okay, so this is how we get the solution of ys and how we prove that we have the correct ys as stated in the question. So proceed to the second one. Based on ys obtained, okay, the previously in 1, okay, find the solution. Okay, so find the solutions. The solution is yt. Just write down your solution is yt. So how to get yt? Okay, gunakan knowledge, apply the knowledge of taking the Laplace inverse of ys. So that is how we play around with the Laplace transform and inverse of Laplace transform. Okay, so just copy your ys. So Laplace inverse of s plus 6, s plus 1, s plus 4. Okay, note that this one cannot be cancelled out, class. Cannot be cancelled out. S plus 6, you ambil sini 6, bahagi dengan 4, bahagi dengan 1 per benda tu. So don't do that. Okay, so mungkin you gelap bila you tengok video ni, ataupun you rasa macam betul ke ni doktor, ada ke orang buat macam tu? Ya, betul, ada yang buat. Mula nak baby ni. So kita tak nak baby, so kita sambung. Okay, so we have s plus 4, s plus 1, s plus 4, s plus 6, s plus 1, s plus 4. Okay, so when it comes to Laplace inverse, recall lah balik. Recall. Apakah the properties yang kita dah belajar? Satu, linearity. Okay, the second one apa? First shift. Okay, and then the third one tu apa? The third one is kita nak melibatkan rational function, we need to apply the partial fraction. Okay, so cuba kita tengok linearity boleh apply ke dekat sini? Tak boleh. Okay, kalau you try to do s over s plus 1, s plus 4 plus, okay, you split into 2 kan, plus 6, okay, s plus 1, s plus 4. So the same thing. So dia tak menyelesaikan apa-apa pun kan. So linearity property is we try to avoid lah dekat sini. Awal lagi nak guna linearity. Okay, sebab linearity pun tak orang kata apa, dia tak possible lah in order to get the idea, in order to solve for this kind of function. Okay, so we go for first shift. First shift saya kata apa? First shift ni betul you yang nampak, oh this one is shifted by negative 6. This one is shifted by negative 1. This one is shifted by negative 4. But the problem is this one dia ada darab ni tau. Dia darab. So you cannot do the first shift unless if you try to expand this function and then you try to get the what we call it completing the square. If you try to do the completing the square so that you can apply the first shift. But now you have integer. When you try to factorize, you get perfect integer here. So it is better you apply the partial fraction. So that is how that is the way you try to think in order to solve for the Laplace inverse at this one, okay, at this stage, in order to get the solution of IVP. Okay, so we proceed. So since I told you in class, in order to apply the partial fraction, I will always try to do it outside of my calculation here. Okay, so saya asingkan. Okay, sebab saya nak kata, I just want to focus on partial fraction. Okay, so I have s plus 6 over s plus 1, okay, s plus 4 equals to, okay, so this one is linear, this one is also linear, okay, so this is a repeated linear. So we will have a over s plus 1 plus b over s plus 4, okay. So we try to cross multiply, okay, and then we try to get only the, what we call it as, we try to get the numerator, okay, because the denominator kalau kita darab sama juga dengan sebelah kiri ni, so tak ada function lah. So yang berbezanya yang kita nak dapatkan is only the numerator, okay. So I will have this one is s plus 6 equals to as plus 4a, okay, I cross multiply, okay, plus bs plus b. Okay, so now I know that both sides of my equation consist of the coefficient of s, okay, and then only a constant. So saya samakanlah macam ni, okay, sebab because I want to solve for a and b simultaneously ataupun menggunakan matrices. This is the idea of matrices, okay. So sebelah kiri saya ada coefficient of s is 1, okay. Right hand side I have a plus this one, a plus b, equation 1. And then when I have s to the power of 1, of course I will have s to the power of 0. S to the power of 0 is just a constant. So saya tulis ini constant lah. Okay. So constant I have left hand side is 6. Sebelah kanan saya ada apa? Oh, 4a plus b, equation 2. Okay. So you can try to just punch your calculator. So maksudnya dekat sini kalau siapa yang menggunakan calculator 570 ms, you try to tekan, okay, press your mode button, mode until you get equation, okay, equation and then unknown, pilih unknown ada berapa? Unknown ada 2. Okay, so masukkan nilai, dia kata A1 apa? Masukkan coefficient of A 1. B1 apa? Coefficient of B, line yang pertama okay, 1. Okay, equals to C1. Dia kata C1 tu apa? Equals to, okay, letak 1. Okay, so nanti dia tanya pula A2. What is A2? 4. Okay, what is B2? 1. Coefficient of B yang line kedua ni 1. Okay, equals to C2. C2 apa? 6. So nanti dia akan bagi jawapan X and Y. X tu apa? X to A, Y to B. So you will get the solution of X and Y directly from your calculator. Okay, because the marks allocated for the method to solve for the simultaneous equation is only 1 mark. Okay, so just do it. Okay, but you need to show this one. Alright, so for those yang menggunakan apa tu nama dia? 570ES. Okay, you can try to find the yang macam bentuk matrices tu, bentuk matrix. Okay, so dia 2 kali 2, 2 by 2 matrix. So you just masukkan 1, 1, this one 1, 1, 1. Line yang kedua 4, 1, 6. Then you will get what is your X and Y. Okay, so X represent your A, your Y represent your B. Okay, so katakanlah dekat sini sebab saya tak ada calculator kan, so saya selesaikan satu persatu lah. Okay, katakanlah dekat sini saya kata B, okay, from 1, B equals to 1 minus A. B equals to, okay, 1 minus A. So saya substitute into 2. I will have 6 equals to 4A plus 1 minus A. Okay, so I have 5 equals to 4 tolak 1, 3 A. So A equals to 5 over 3. I hope that my calculation here is correct. Okay, but I already told you on how to use the calculator. Okay, so here I have 1 equals to 5 over 3 plus B. Okay, so B equals to 3 over 3 is 1 minus 5 over 3. So I have B equals to negative 2 over 3. So A equals to 5 over 3, B equals to negative 2 over 3. And then I go back to my Laplace inverse. So Laplace inverse of S plus 6 over S plus 1 times S plus 4 is actually can be simplified, okay, into the form of A over S plus 1 plus B over S plus 4. And this time only I can apply the linearity property, okay, linearity, because I can split it into 2. So, and then I have A, here A is a constant 5 over 3. So I have 5 over 3 Laplace inverse of 1 over S plus 4. Okay, so I split it into 2, okay. So B, what is B? Negative 2 over 3. Oh, minus 2 over 3 Laplace inverse of 1 over S plus 4. So I hope that my calculation here, step by step, one by one, I hope that you will get clearer picture on how to solve this one. So I have 5 over 3. Oh, 1 over S plus 1. S plus 1 shifted by A. So I have S plus 1 should be E negative T. Minus 2 over 3. Oh, this one is shifted by 4. Sorry, shifted by negative 4. So I have E negative 4T. Okay, so kalau tak percaya, try to take the Laplace transform of your YT. Check whether you will get the same YS here or not. If you get the same YS, means that you have correct YT. Okay, so maksudnya jawapannya betul lah. Okay, so that is the first example of this video. So I will park this video on Edpuzzle. I really hope that everyone can watch this video. Okay, thank you guys.
Are you ready? Let's go!